Hi, folks. It's great to be alive. Um, it's, uh, I'm just trying to spot how many people in the room remember the old hair. Uh, from the time before. I mean, this talk is hopefully a bit of fun and a bit of propaganda, and it's mostly pleading to the people who build things to think about stuff before they make foolish decisions. Um, I need to sort of talk about the evolutionary structure of kind of the type world we live in. So, for example, before the creation, things were just impossible, and then God crossed out zero and wrote one. And before the fall, we were completely happy with everything because we weren't discriminating about anything. But then Satan got to her persuasive work, crossed out one and wrote two. And now things were true or false. And it was possible to do logic. And then somebody spoiled everything by crossing out two and writing nat. And now we were able to count the things, not just decide whether there were things or not. And it became possible to invent capitalism. Yes. 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 Uh, but then people crossed out nat and wrote set. It's like, so instead of just knowing that you had five things, you could have Bookends, Pumice Stone, West Germany, Wolverhampton Wanderers, and Reykjavik. But and that kind of got far too chaotic. So sensible people crossed out set and wrote type. And now at least there's some vague sense of a common interface to the collection of things. There's some notion of evidence. We're not just counting things, we are actually being systematic about stuff. And all of this represents progress. And I like progress. And this talk is about getting more of it. Because what I want to do is cross out type and write something else. Okay, so start with an example. I'm gonna uh, do some. I've got an old version of this talk here. Some of it I'll just move the piece of paper up, but some of it just needs to be built up slowly. So, favorite example is, of course, terms indexed over the natural numbers. Right. Things have gone wrong already. Right. What's gone wrong already? This is the type of natural numbers. What is this definition going to respect? It's going to respect equality of natural numbers. That's, at least something sensible, but it's not very ambitious, is my problem. Okay. So there are going to be three kinds of terms. There's going to be applications, which take a pair of term ends. And there's going to be lambda, which takes the term 1 plus n. And then there's going to be variables, which take some x in n choose 1. And n choose 1 is a binomial coefficient, except that I've crossed out nat and written type. So that we could actually collect the evidence of which things have been chosen. So the evidence of which one of the n we chose is a perfectly sensible way to represent picking a variable from the n variables that are in scope. Okay, and then correspondingly, there will then be an action of binomial coefficients on terms. Or rather, hang on, that's just something I'm pulling out of my arse right now. Right, so I've got some t in term n, and I've got some theta for thinning, in m choose n, and I'm going to get a term over m variables. This is not in the slightest new. I learned this from Torsten years ago. And it's going to be, you know, app fs theta. I'm just writing as a postfix action is app f theta s theta. And we've got lam t acted on by theta is lam of t acted on by theta snock 1. By the way, binomial coefficients are vectors of bits indexed by, on the one hand, their length, and on the other hand, their population count. So these are snock vectors of bits with a useful extra piece of information telling you how many ones there are. And then we've got var x beta is var x then theta, because of course these things being order preserving injections have categorical structure. So there is a composition which says if you've chosen one from n and you've chosen the n from the m, then you could surely put them together and you've chosen one from the m. So what I'm saying is that the binomial coefficients give you the category of thinnings, or the opposite of the category of selections. And in fact, there's a perfectly sensible functorial action of that category on these terms. However, that's something that I kind of decided to bring into existence by brute force. These terms were not born with a functorial action of thinnings, and I put it to you that they might have been. So what I'm saying is that I want to cross out nat and write selection op here, and I want to observe that this thing is positive in n, and that what's more, this thing is a functor from cell op to cell op. And if only we actually noticed which category we wanted to work in, right? This nat, you know, we're basically just saying, you're only allowed to index by discrete categories. You know, how tedious. Why can't we index over more stuff than that? And then observe when stuff from the Hom sets of that category shows up in the data in such a way that we're guaranteed an action by composition like this. And whenever we monkey with the index, we have to make sure we monkey with it in a way that's functorial. But apart from that, if we're actually noticing this, then we get this structure for free. Gabriel.
You're going a bit fast. Can you remind us what cell is? So I guess
cell is the category of, or sometimes semi-simplicial category, but it's the category of choosing n things from m things. And then if you op it, you're about saying we're injecting n things into m things.
And positive in n, what does that mean?
It means that in cell op, this is a morphism from 1 to n. The n's on the the n is the codomain. The n's on the right, and correspondingly, there's an action by post-composition. Okay, so that's a good game to play. How long have I got? Cool. I'll switch to ones I prepared earlier. So yes, that, by the way, is your is the construction of the. I mean, it's basically Pascal's triangle, except that instead of counting the the number of choices, you actually recognize that each path in Pascal's triangle represents a different selection. Ask me in the bar afterwards about Eric the cigarette. I'll tell you a stupid story. Right. Right. So I'm a big fan, it's a pity nobody else is, of universes where we give first-class representations of data type descriptions that we then reflect as the data types of our systems. So, at the moment, the single biggest crime against against users committed by the providers of our systems is the generative inductive data type. There is no way to introduce a data type other than going, fuck me, I've had a brilliant idea for a data type. They never come from somewhere. You just have to pull them out of nowhere, right? So I really like having actual, take the syntax of data types and turn it into a data type itself so that you can actually manipulate in a first-class way the descriptions of data type. And I want to do this in such a way that I'm going to get functoriality for free. Okay, so it turns out I'm interested in constructing, so I want the Fs whose fixed points I can take to get things indexed by C that are functorial non-trivially. So that means I need to be able to get the thing I'm going to take the fixed point of, which is going to live in C to type to C to type. And in general, I'm going to need to break the connection between domain and codomain. So I'm just interested in functors from C to type to D to type. So with an interpretation like this. Okay, so I define them inductively as follows. You can have the identity if C and D match. You can, if you happen to have a functor from D to type in your back pocket, such as the HOM functor, you could just have a constant for D to type. You've got pairing, you've got unit, you've got sigma over some set of tags. I wonder if we can do better than that, actually, with a bit of co-endy goodness. And you can pre-compose any other functor that you happen to know about. Sorry, post-compose it. Oh, sorry, this is going to get us a C to D from a D to E and a C to E. Yes, so we're so that's going to work out. I've got somewhere got the interpretation of these things, but there's only one thing it can be. Right. So we have to say when we've got the interpretation of this and we've got some X in C to type and we've got some index in D, what have we got? And we've got well, if we get the identity, then we actually use X. If we get a constant, then we use the constant. Unit, we get unit. Pairing, we get pairing. And the nice thing is, when we get composition, we use F's action on objects to we move that into the index. So correspondingly, I get this thing. I get that term has a description as a functor from thinning to type that I'm going to take a fixed point of, and we have a sigma over some tag set var at lam, and then for var we have the constant hom functor from 1. For application we have a pair of recursive substructures, and for lambda we do the add one functor and then have a recursive substructure. If you write down the description of the terms this way, then by construction rather than by hard work, you've got your functor from thinnings to type. And more of that, please, if we may. I see Jake has a question. I should also advertise Jake's colleagues who are into, in particular, Mevin. Are you talking later? Yes. Okay, cool. But yeah, this stuff fits very nicely with the story about functorial adapters. So more movement in that direction. Jake.
Well, after that comment, my comment's going to be, or question's going to be a lot simpler. Plus
Yes.
one, is that the sigma type non-dependent, and then one being the one from earlier, the unit from earlier?
Sorry,
what does
the
plus one functor mean?
a plus one functor is saying not only do I want one extra variable in scope, but that if I'm pushing where did it get to? If I'm pushing a thinning under a lambda, I should be mapping the new bound source variable to the new bound target variable. So that's the functorial. So just SNOC 1 is the action of the plus one functor on thinnings.
Thank you.
So yes, people who build stuff, build us this. I mean, I'm a person who builds stuff, so I'll build us this. It's just, you know what happens to things I build. I'm packing up to get out of the way, but please do ask.
Now we get to ask as many questions as we want, because we don't want to say more stuff before we ask questions. Is that right?
That's fine. I'm done.
Okay. So, okay. So you had this L construction that returns a type, but I would expect that there was another slide where we see, I don't know, the action of the functor on.
Oh yeah. Sure. You have to imagine that, and what's more, you also get the proof that it respects identity and composition. And if you have any wit, you engineer the definitional equality of your type theory to include that functoriality.
My question is, why is it not on the same slide? Why do you go to sets instead of to something with more structure, so that we do everything in one go?
Potentially, that's I mean, that's I need to have some data in the first place, but yeah. So indeed, I could. The sensible thing to do is indeed to sort of build all of those constructions at that level, at the level of. So sometimes it gets a bit tricky, because you need the action on objects before you can, for example, take the fixed point. So it's one of these annoying chicken and egg situations that you've got a little bit of work.
So, hey, I saw a remarkably similar talk to this just a few weeks back at Harvard, and it was about something called directed homotopy theory, or directed homotopy type theory. Can you explain, like, are you saying we should be doing directed homotopy type theory, or are you saying, or is this something else? Like, what's the relationship?
I think that there's no actual necessary connection between directedness and homotopy type theory. You can actually do this in any setting, but of course, it's the machinery of transport, and the way that works looks as if it could easily be made just covariant, or rather that there's a co-contra thing that happens in negative positions with transport. It smells so much not just of equality, but of subtyping. And so correspondingly, if you didn't have me turning up and saying, hello, think about interesting transport operations on structure other than equality, homotopy type theory would send that message to you eventually.
Thinnings aren't the only useful base category here.
Correct.
How do you propose to be kind of polymorphic over a two-categorical sketch?
Well,
because eventually you want to tie the knot, glue the chicken and the egg together, and get substitution.
Yeah. So indeed, I certainly want to have categorical structure as a kind of recognized ingredient of the system. So it's not just that I'm talking about thinnings, that we're actually talking about notions of category that are represented, as the right equipment, and that we are explicitly, when we declare a data type, or defining a data type in this way, we're explicitly saying what structure we're respecting when we index over things. So I think, I mean, yeah, sure, we like syntax with binding, but it's very much not the only game in town. Defining relations on terms that respect, oh, I don't know, the reflexive transitive closure of reduction. It's not a daft plan, is it? So yeah, there's lots of gold in this mine.
Last question.
Hello again. So on the more practical side of this, in terms of actual implementation and using it, so I believe Agda can do what you're talking about right now. I think it's in the standards tutorial for defining polynomial functions and fixed point values. I just want to confirm that is what's going on. And also,
well, indeed, github.com/pegworker/samizdat/defunct.agda will sort you out.
Following on from that as well, would you, if your sort of goal was reached, would we just get rid of the data keyword at all and just do everything in this fashion?
Yeah. Well, certainly. I mean, it's the classic joke that we used to tell about airport security in terrorist situations, where your luggage is inspected, including the very toothpaste in your toothpaste tube, and then the security officer hands it back to you saying, here is your toothpaste and here is the tube it came in. You now have a problem. So I always advise people to think carefully about the toothpaste to tube orientation